This reaction proceeds spontaneously at standard conditions. A. Predict the sign of the entropy change for the reaction. Explain. How would the value of delta S naught for the reaction change if the product of the reaction was water in a gaseous form? C. What is the sign of delta G naught at 298 Kelvin? And D. What is the sign of delta H naught at 298 Kelvin? The sign of the entropy change will be negative, since there are 3 moles of gas on the reactant side, put a 1 there, and none on the product side. It's all liquid. So the entropy change will most likely be negative. As gas moles are converted to liquid moles, the molecules are less dispersed in the liquid form, which translates to a negative entropy change. The change in entropy would still be negative, even if the product of the reaction was H2O gas, water in a gaseous form. There's still 3 moles of gas on the reactant side and 2 on the product side. There is still a reduction in the number of moles of gas, but less so. The entropy change would still be negative, but again, less so. What is the sign of delta G naught at 298 K? The change in Gibbs free energy is negative because it was stated that the reaction is spontaneous at the given conditions. What is the sign of delta H naught at 298 K? The change in enthalpy, delta H naught, will be negative, and we see that by considering the Gibbs equation here. We know that delta G naught is negative from part C of the question, and delta S naught is negative from part A. So if delta S naught is negative, minus T delta S naught is positive. So the only way we can get the right side of the equation to be negative is to have delta H naught as being a negative number.